They are indeed.
For sine and cosine and tangent. Alright, so first thing we're going to start in our notes here, and you'll remember most of this from Algebra 2 and Geometry. We're going to label the ratios for all 6 trigonometric functions. Okay, those are the 3 that you remember the most, that you use the most, sine, cosine, tangent. But there are 3 additional ones, the reciprocals of those, and you need to write them across from each other like I'm writing them, so we'll keep them matched up. There's cosecant, secant, and cotangent. Okay, remember this is our opposite and hypotenuse and all that stuff. Lots of different ways you can memorize that. Some people will say SOHCAHTOA. When I took Algebra 2, this is the way I learned it. Oscar has a heap of apples. So I've remembered Oscar has a heap of apples for all my life now. One kid taught me one time, oh heck, another hour of algebra. I thought that was pretty funny, so I use that one a lot. I don't use the one about the hippies on drugs. That's stupid. Whoever told you that, Mr. or whoever. Yeah. Ask him about your table. They know it.
Some old hippie, cognose hippie, tripping on acid.
See?
I
Some.
moved to bed in my friend for a year, so I didn't know that.
Anyway, SOHCAHTOA is pretty common. You can use SOHCAH, SOHCAHTOA, like somebody, I read it online one time. Somebody like went into a whole elaborate story about a Native American named SOHCAHTOA and how he went hunting and found all these triangles, and somebody's got a little too much time on their hands, but wasn't me. Okay, now the one I wrote straight across from it are easy to remember because you just take the reciprocals. So if sine is opposite over hypotenuse, that means cosecant is hypotenuse over opposite. You just flip it. And we're doing this stuff in Algebra 2 right now. They've got a test over it tomorrow. And one thing that I'm fighting with them on is when they take the reciprocal, they keep wanting to put change the sign, positive or negative. But the sign, positive, negative doesn't change. If it's positive, it stays positive. If it's negative, it stays positive, stays negative. Cosine.
Well, they want to change the sign.
Yeah, because I screwed it up. Cosine, the reciprocal of adjacent over hypotenuse, will be hypotenuse over adjacent. And then cotangent, the reciprocal of opposite over adjacent, will be adjacent over opposite. Okay, so first thing we'll do is work through a problem or two with that, and then we'll move on to our next identity. Everybody got what we need there? Alright, let me get us a triangle. My little shape drawer on this thing is a little bit more limited. It only draws an equilateral right triangle, and I don't want an equilateral one, so we're just going to pretend that it's not. I need that to be like scalene, or not isosceles, so we're just going to pretend. Alright, we're going to name this one D, and this one E. We'll name our right angle down there F. Okay, this is 85. Again, we're pretending right here. 77 and 36. Because that one obviously is not that much longer, but we'll pretend it. Okay, so our directions here, we're going to start with angle D. Say to tell the 6 trigonometric functions of angle D. Okay, so first thing you got to do is find angle D, and then you got to know what all of your stuff is. What is opposite of D, what is adjacent of D, and what's the hypotenuse to D. So let's start with hypotenuse. It is the 85. There's 2 ways you can know that. Tell me one.
It's the longest.
It's the longest. That's one way. What's the other way?
Opposite.
Opposite the 90-degree angle. Very good. Always the longest. Always opposite the 90-degree angle. Alright, so 85 will be the hypotenuse no matter which angle you're using. But the opposite and adjacent, it depends on which angle you've got. I've highlighted D. We're looking at D. So 77. What would 77 be to D? Opposite or adjacent? Adjacent. Very good. And my dumb words for that is it's touching it. If it's touching it, it's adjacent. 85 is, but 85 has to be the hypotenuse. So the only other one touching angle D is 77, which means the one not touching it, 36, is opposite. You got it. Okay? So now we can fill all this in here. The sine of angle D, opposite, I'm writing a 6 in it, there it is, over hypotenuse. If that stuff reduces, you got to reduce it, but in this case they don't. The cosine of angle D, adjacent, keep going, over. Good job. And the tangent of angle D?
36
Oh,
So,
77. Tangent's O over A. O over A. Okay. Now, once you get those three, it's easy schmeezy to get the reciprocals because you just flip them. So cosecant, I flip sine. So flip it to 85 over 36. Secant, I flip cosine. 85 over 77. And cotangent, I flip tangent. 77 over 36. I know most of y'all are probably already done taking the ACT. I hear all the time people, well, I don't want to take the ACT till we cover trig. Well, there's only like 4 questions worth of trig on the ACT, and most of those 4 can be done using that. So I just always laugh at them and tell them they don't got a clue. All right, first period then, we went through E also. I'm not going to make us write all 6 of them for E, but I do want you to label your stuff for E. So looking from angle E, what would the hypotenuse be? Still 85. Good, it doesn't change. Hypotenuse is the same no matter what. From angle E, what would 36 be? Adjacent. Very good. And from angle E, what would 77 have to be? Opposite. Very good. So y'all could handle that. No problemo. All right, the next thing we got to look at, we're going to write some rules here. These are called cofunction identities. And I got about 6 of them I'm going to write down. Identities, maybe. That's ugly. All right.
I have a question.
Yes, sir.
On angle F on that,
Let me go back. Yeah.
how would you do the opposite?
Good question. Chase is asking about the right angle, and that's a good question. You don't use the trig functions of the right angle ever. It has to be one of the acute ones. And that's a good question. Thank you, sir. All right. So cofunction identities, first one that I got is sine of A is equal to cosine of 90 degrees minus A. Then I've got cosine of A is equal to sine of 90 degrees minus A. And I've got secant of A. Whoa, we got a triangle popping up on me. Secant of A is equal to cosecant of 90 degrees minus A. Then I got cosecant of A is equal to secant of 90 degrees minus A. So they're all the 90 minus A, obviously. 2 more. Tangent of A is equal to cotangent of 90 minus A. And the last one, cotangent of A is equal to tangent of 90 minus A. Alright, I know you don't remember back to our fun algebra 2 days all the time, but when we did our trig unit, there are a lot of different identities. You got the most common, or the Pythagorean identities, which actually came from the Pythagorean theorem. So you got Pythagorean identities, you got reciprocal identities, you got cofunction identities, and there's even some more that I'm not remembering right now. There are a whole list of identities. We copied down a whole page of it when we were doing this in Algebra 2 the other day. But all we're dealing with today is cofunction. Okay, that's it for today. So get that down, and we'll use that to answer 3 or 4 questions. So using those here for the next 3 or 4 questions, what I've got for us says cosine of 52 degrees. Here's what the directions say. Write the function in terms of its cofunction. So that 52 degrees right now, that would be like angle A. So what I'm looking for, if I got to use a cofunction identity for this, I'm looking for the one that says cosine A equals something. So find what you wrote. What does cosine A equal? Sine of 90 minus A. So like I just said, all I got to do is plug 52 in for the A's. Okay? So the cosine of 52 degrees is equal to the sine of 90 minus 52. And we just got to figure out what 90 minus 52 is. Anybody know? 48?
38.
38. Thank you, thank you, thank you. That's it. That's your answer. Okay? Now we'll get into using the calculators a little bit tomorrow and more next week and learn how to be in the right mode and all that stuff that I talked to Caleb on yesterday.
Yeah.
But when we use our calculators correctly, what this is telling me is that if I hit cosine of 52 and sine of 38 on my calculator, those will be the same. It's the same measurement on that. Okay? Let's do one more of those before we go to the next phase. Let's say I gave you the tangent of 71 degrees, and the directions are the same. Write the function in terms of its cofunction. So you're looking for the one that says tangent, because it gave you tangent. Tangent of A is equal to what? No. Cotangent of 90 minus A. They're all 90 minus A there. Got it? Okay, so we plug our 71 in. So cotangent of 90 minus 71, and we get cotangent of 19 degrees. That's it.
That's what I meant.
Oh, I was confused. I'm sorry. Grace was ahead of me. She's working smart. All right. Now, it's key that we note that we subtract them all for 90 for what we're fixing to look at on the next one. Okay, everybody got what we need? All right, here I've got cosine of theta. That's a 0 with a slash through it. I'll talk to you, remind you about that in just a second. Plus 4 degrees is equal to sine of theta, 3 theta. That needs to be a 3 theta. 3 theta plus 2 degrees. That's a 3 theta there. It's all jacked up. All right. Theta, T-H-E-T-A. Remember, that is the variable that represents an angle. In algebra, most of the time we use X. Theta is just that symbol that they use in trig. You can replace theta with an X or an A or whatever you want to if you prefer, but that's trig talk. If you're doing angles in trig, you're going to see that 0 with the little slash through. It just means an angle. Okay? All right. We said earlier that if we had cosine and we were using a cofunction identity, we would subtract it from 90, right? So the only identities I've given you so far today are the cofunction identities. So we got to be able to use one of those. That should be common sense to you. I'm not going to expect you to remember something that we haven't reviewed yet. So we're looking at cofunction identities. So if I have one of the trig functions, I subtract it from 90 to get the other. So what if I have them both? What would the two have to add to? If I had one earlier, I subtracted it from 90 to get the other one. No. So now I got two of them. What would they have to add to?
180.
No. That's what Zane had. 90. Very good. If 90 minus something gives me the other one, something plus that's got to equal 90, right? So since these are of the same cofunction, you can look at them, cosine and sine. They jive together on those cofunctions you wrote. All you got to do here is take the stuff, add them together, and set them equal to 90. So we got theta plus 4 plus 3 theta plus 2 has to equal 90. And it turned this to a basic algebra equation here. Combine your like terms. Don't get bogged down by the theta. It's just like an x. So what's a 1x plus a 3x? 4x. So I'll put 4 theta. Then on my numbers, I got a 4 plus a 2. And you got a two-step middle school equation. Subtractamundo. So 4 theta is 84. So divide by 4, and what's theta? 21 in its degrees, and that's it. So when you have the two different trig functions that are cofunction identities, they have to add to 90. Okay, so that'd be a good thing to know on that. We're going to do one more of those. Real moss. Here I've got cosine of theta plus 4. I think I'm doing the same one I just did. Yeah, that's the same one you just did, stupid. Try again. Here I got tangent. Could have done the same one again, only two of y'all would have noticed. Of 2 theta minus 18 is equal to the cotangent of theta plus 18. And both those 18s have degrees on them. Alright, so you need to check and make sure that this is doable on your cofunction identities. Do tangent and cotangent job together? There, we wrote those on the same. Good, so it's good to go. We just got to take this stuff, add them, and set them equal to 90. Okay, so I got 2 theta minus 18 plus theta plus 18. What'd you say, Caleb? Oh, yeah. Yeah. I thought I messed up again on something and you were fixing. Gotcha. What happens to your 18s here? It's what Caleb's talking about. Good. You got a negative 18 and an 18. They gone. What about your thetas? Yep, you got 3 of them like Zane said, because 2 plus 1 is 3. Last step, divide by 3, and what's our angle? 30. 30 degrees. Alright, going to be referring to that unit circle I passed you around now. So have that handy where you can look at. I need you to write a few things on it for me that are going to benefit you a lot. Those ordered pair that go around the perimeter of that circle, those are in the order of cosine comma sine. So whatever's in the x place will be the cosine of that angle. Whatever's in the y place will be the sine of that angle. Okay, and that's pretty handy. I would definitely make sure I remembered that. We talked about it a little bit before the last test, but not a whole lot. But that's pretty big right there. Now, you're like, well, it tells me cosine and sine. Why doesn't it tell me tangent? And that's a good point, but it helps us get it. Write this wherever you wrote that. Tangent you can get by doing your sine divided by your cosine. Okay? So that's why I was saying the unit circle is full of answers. It's got a lot of stuff on there. Now, obviously, those aren't all of the degree measures, because I could have a 62 degree angle, and the unit circle doesn't have 62 degrees, right? I could have a 183 degree angle, but the unit circle doesn't have 183. It only has major ones that you get from your 45-45 90s and your 30-60 90s. Every now and then you'll have something different. That's when we'll get into using the calculator a little bit. All right, so what we're going to do here is we are going to give all 6 trigonometric functions for a 30 degree angle. So we're going to tell the sine, the cosine, and the tangent. And then we're going to tell the cosecant, the secant, and the cotangent, all for a 30 degree angle using only that unit circle. Okay, so find 30 degrees first off. That's step 1. I got it? Tell me what is the ordered pair associated with 30 degrees? Uh-huh.
The square root of 3 over 2, comma 1.
Alright, so that's what we're dealing with. I wrote it up there in red. Square root of 3 over 2, comma 1/2 is your ordered pair. That tells me already my sine and my cosine. Which one of those is the sine based on what I just had you write down? 1/2. So the sine of 30 degrees is 1/2. So the other one is your cosine. Square root of 3 over 2 would be your cosine. Alright. Now you're going to do a little bit of work on some of these when you've got radicals involved. Tangent, we said, you wrote, is sine divided by cosine. What's the rule when you divide a fraction?
Multiply by the reciprocal.
Close.
Multiply.
Multiply by the reciprocal. So we're going to do 1/2 times 2 over the square root of 3. 2's will cancel. So you're looking at 1 over the square root of 3. Can't leave a radical on bottom. What could I do to this to cancel out the square root of 3 on bottom? Good, Kirsten and Caleb. Multiply by the square root of 3. So we have square root of 3 over 3. So that is your tangent. Square root of 3 over 3. Now, to get these, all we have to do is take the reciprocal of these. And that's easy schmeezy, except for when we run into those radical issues. The 1/2 is not any deep thoughts on it. Flip 1/2, you get 2 over 1, so my cosecant would be 2. This one's going to be a little bit tougher. If I flip 2 over the square root of 3, I want to keep this up here, so let's write a little over here. If I got 2 over the square root of 3, if I flip the cosine, I have to do what Kirsten and Caleb said, multiply top and bottom by square root of 3. So I get 2 square roots of 3 over 3. So that'd be my secant. I would, Grace is right, do the same with the cotangent, but I left my work up there on tangent on purpose because I think we can trace that backwards to a place where we won't have to rationalize. Here was our final answer for tangent. So good, you're there, Zane. I could flip that and rationalize the denominator, but look back a couple of steps. Wouldn't this be okay? Just that one I wouldn't have any work to do if I just flipped that part of it, right? Because that would put square root of 3 over 1. Now, would that be the same answer if I did the long way and worked it out? Yeah, let's look at why. If I took square root of 3 over 3 and flipped it, it'd be there, right? If I flipped this, then I had to multiply top and bottom by square root of 3, so that'd be 3 square roots of 3 over 3, and then your 3's would cancel. So you get the same thing. Just don't panic if you have to go back and work something. Alright, so you can, I'm going to make you a chart here in just a second, but I want you to answer a couple of questions for me real quick. Tell me, what would the tangent of, no, I don't want to do that. What would the sine of 60 degrees be? Kirsten's got it. Everybody see what she said? Square root of 3 over 2. Just making sure y'all can read that because that sounds silly, but you gotta. That's a lot of your questions that you'll have. So what is the cosine of 45 degrees? Yep. Wonder why on 45 it's the same? Anybody think about that? So if you've got, your axis gives you the 90 degree angle, right? So then you got another one's 45. What does the third have to be? You got 90 and 45. What would the third angle of a triangle have to be? You know it because right, it had to be 40. So you got a 45, 45, 90. So that means that 2 of your angles are the same, so 2 of your sides have got to be the same. So that's why that's always crazy to me how that works out like that. But all right, we're going to make a chart similar to what we did there with 30 degrees, and we're going to look at, I thought my page went, there we go. We're going to look at 30, 60, 90. Not 30, 60, 90, dummy. 30, 45, 60. Because like Chase already said, we don't use the 90. So we're going to label what the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Now this chart that I'm fixing to help you make is not something that's completely necessary because like what we just did for the 30 degrees, you can do that on your own. But this is just a little time saver chart here, so you'll already have the major ones that are asked the most often. Now you'll already have all them written in your notes. So just a little time saver chart for you. Alright, we already got all our 30 degree ones. I've turned my page, so I'll recopy them for you there. The sine of 30 was a half. The cosine of 30 was square root of 3 over 2. The tangent of 30 was square root of 3 over 3. The cosecant of 30 was 2. The secant was 2 square roots of 3 over 3, and the cotangent was square root of 3. Alright, so look at your unit circle, and y'all just told me this just a second ago. Tell me what the sine of 45 degrees is. That's square root of 2 over 2. And then what I was talking to Rachel about, the cosine on 45 is the same, isn't it? Square root of 2 over 2. So then when we go to our tangent, what do you get when you divide something by itself? 1. Very good, Zane. I got mad and yelled and screamed at first period because I said, you have 2 weeks of math left in school and you don't know what something divided by itself is. And then I went nuts. It was not fun. And then I talked about Barbara Bush and they thought she was George Washington's wife, and I went nuts again. Oh. Anyway, cosecant, when we take the reciprocal of 2 square root of 2 over 2, you end up getting just the square root of 2. Secant, you end up also just getting the square root of 2. And then cotangent will be 1. Alright, start me out on the 60. Find 60 degrees. You've already said it once a second ago. Tell me what the sine of 60 degrees is. Alrighty, and what's the cosine? Okay, now I'll fill in the rest with you. Tangent, when you divide that, would be square root of 3. Cosecant will be 2 square roots of 3 over 3. Secant will be 2. And cotangent would be square root of 3 over 3. Alright, so whole moral to the story point of that, like I've said 3 times now, time saver chart. You got an assignment coming up this week or next. You got a test coming up this week or next, and it asks for the cosecant of 45. You could find it, or you could just look on your chart and copy it down. Okay, so if that were to happen, you've got a head start on that. Alright. Tomorrow's stuff gets into more on the unit circle and also more on the calculator, doing some angles that are not acute, because if you look at that unit circle, it goes all the way to 360, so it passes 90, so it gets to some angles that are not acute, so we'll have a little bit more stuff to talk about tomorrow. Okay, everybody good? Alright, how do we wrap it up? What's up, GG? Sure.
Is it open if I just come in at lunch?
Yeah, that'd be fine. If you don't finish and you come back some